Cecilia Caretti, who is a researcher at the University of Florence, Department of Civil and Environmental Engineering, project manager of Life Less Water on the energy and carbon footprint minimization in water resources recovery facilities. So, thank you.
So good evening, everybody. And yes, which is the context of our project? As we all know, the water recovery facilities are sources of both direct and indirect greenhouse gases emissions. And the direct emissions are mainly produced by biological processes, while the indirect emissions are primarily due to the energy consumed to operate the plant. And since the aeration tanks account for about 50–60% of the total energy requirement of a water resource recovery facilities, it is therefore the major sources of indirect greenhouse gas emissions. Therefore, the optimization of the oxygen transfer process is very important to reduce both energy cost and the carbon footprint of the plants. A proper on-site monitoring of the oxygen transfer efficiency and of the greenhouse gas production is essential for assessing the best aeration process management in order to minimize energy consumption and carbon footprint of the plant. In this context, our project design and implement an innovative tool which assesses the direct and indirect contribution to the carbon footprint due to the oxidation processes in the plants. The proposed solution includes both a prototype, the LESDRON, which I will show you, and a protocol which translates the information collected by the drones and the information collected by the plant manager into action aimed at minimize the carbon footprint. The LESDRON is an automated and self-moving device which moves on the surface of the oxidation tanks and which is able to capture the off-gas from the oxidation tank's surfaces. It is propelled by 8 motors and it is remotely controlled and we can choose the measuring path by the GPS. The prototype consists of a foldable steel and support frame carrying 6 cylinders, and a wood mounted at the center of the frame conveys the off-gas into collection pipe. On the upper part of the hood, there are 2 boxes, one containing the analysis instruments and the other the control and the positioning devices. The gases, after passing by an anemometer to evaluate the airflow rate, passes through the sensor for the oxygen, CO2, methane, and hydrogen peroxide measurements. And the probe for the dissolved oxygen and the temperature measurement in the mixed liquid is also present. The LESDRON evaluates the oxygen transfer efficiency by the off-gas method and measures the greenhouse gas concentrations. By means of the airflow rate which is calculated, we can assess not only the concentration, but it is possible to have a mass balance of the production of these gases, and we can have balance compared with the inlet in the plant and considering also the biological processes in the tanks. An off-gas aliquot can also be conveyed by the LESDRON in nylofan bags in order to measure the volatile organic compounds, hydrogen sulfide and others. and we are now working on a sensor which will be applied directly on the wood. The measurement test, we have two kinds of test, point test, which consist in measurement in different points of the oxidation tanks. And this allows us to have the special distribution of the parameters that we measured. And this is very important since in the oxidation tanks, the airflow rate is variable along the tank, and the plant manager has no the sensor and the instrument to know how the air is distributed, and also all the characteristics that we measure are very variable within the tanks, and this allows us to see if there are zones, areas in the surface of the tanks which are not homogeneous, and the plant manager can decide how to manage these differences. Moreover, there are stationary tests, so measurement in single points for a long period of time. We did measure up to 1 week, and this is important to have the temporal distribution in different operating conditions, since we know that the greenhouse gas emissions and the oxygen transfer efficiency is very variable during the day, during holidays and working days, night and days, and with the different organic loads in the inlet. We did 1 year of experiments in a test plant, the largest tannery wastewater treatment plant in Italy, and then we validated the method used in 2 plants in the Netherlands, and other 3 big plants in Italy, in Rome, in Florence, and in Reggio Emilia. The different context in which we applied this methodology was important in order to evaluate the transferability and versatility of our new technology. Here are some examples. So we can see here the variability of the oxygen transfer efficiency of the air and of the oxygen dissolved inside the tank. Moreover, we use this instrument as well as a diagnostic instrument, since, as we know, most of the aeration processes use diffusers in the oxidation tanks, and we evaluate the different ages of the membranes, and we evaluated how these could affect the oxygen transfer efficiency. Moreover, we evaluate the greenhouse gas emission, and not only with the spatial distribution, but also the temporal distribution. And this showed to be very important, because a single point is not significant, because we saw that it depends on the moment when we do the measures. So in biological treatments, especially if the plants treats water with a different characteristic, so not only urban wastewater, but also industrial wastewater, the greenhouse gas emissions are very variable. And so a precise concentration measurement is not is not significant for the plant manager. In one of the plant, we measure the along the tanks. We tested for the organic volatile compounds, but in the oxidation tanks, neither of them were detected, and all the values were very low. And this was also true for the hydrogen sulfide and the Odour unit. But as I told you, we are now trying to put the instrument on the wood in order to be able to have concentration of this value, concentration of these chemicals, but also the value of the flux together in order to know the emission rate of these compounds produced by the oxidation tanks. So coming to the conclusion, the Lestron allows the aeration process assessment of the carbon footprint. The output of the drone proved to be reliable, repeatable, and accurate. And the ability to move around inside the aerated tank ensures the complete automatic mapping of the tanks. So it is possible to leave the instrument for 1 week, and the instrument will measure alone all the data. It can be controlled remotely with all the data which can be controlled by a simple PC. The data acquired are consistent with the plant process conditions, and the instrument not only highlighted the spatial distribution of the airflow, but also assessed the total airflow by extrapolating the values measured at different points. And this is an important information since most of the plants, at least in Italy, do not have an airflow meter in every oxidation tanks. So the problem is that it's easy to have perhaps the concentration value, but if you don't know the corresponding airflow value, you cannot make a mass balance. Moreover, the experimental outputs and the data collected by the plant and by our modeling activities allows to assess the optimal airflow rate and dissolved oxygen to ensure the pollutant removal, which is the main goal of water recovery facilities, and the minimization of the carbon footprint during different climatic and process conditions. So in order to vary the process control while varying the process condition. This method also allows the plant manager to optimize the methods and the frequency of cleaning or replacing the submerged air diffusers. And it is possible to collect off-gas samples for the analysis of greenhouse gas emission, but also of VOx and Odour. The functionality and versatility of the method makes it possible to apply this solution in different contexts. And this is why we have already contact with other 10 European plants where we will carry out other measurement. So thank you for your attention, and if you want to have information about the results, the project website is, you can find all the information in the website, and otherwise we can just ask us. Thank you.
Thank you for your talk. It's a very interesting topic because it's an innovative strategy to do process control in wastewater treatment plants. I ask to audience if there are questions. Laura.
It's just a curiosity more than a question. You showed us results on aerated tanks. Is the technology also usable on non-aerated tanks, so on sedimentation tanks or?
This is designed for aerated processes because the main goal is to assess the oxygen transfer efficiency and the greenhouse gas emissions. But we have a similar tool for the anaerobic, let's say, tanks, but the principle is different because we have an artificial flux, okay? And we measure the concentration and therefore the emission rate. But the problem is that is related to the flux that we we put inside to have the. So in this case, the measure is only related with the concentration and not for a mass balance.
Oh yes. And one other curiosity, what do you believe would be the cost of one of these systems?
Of the systems?
Yes.
Is about 40,000 euros. 40,000 euros, okay.
Okay,
That's why we don't, I mean, we can sell the instrument, but the business core is to sell the service, because the plant manager asks us to a diagnosis of the plant, and so perhaps we can do tests on different seasons, repeated tested, but with the instrument of the university.
Okay, thank you very much.
You're welcome.
Are there other questions? No. So I think that this is the end of the session about drones. And so thank you very much.